Hi, this is YanchengDing, and I'm doing the presentation for AERO4842 spacecraft designed to optical microscope. So the project I'm doing is an optical microscope that can capture images on biotas and thin samples. The picture on the right is an overview of my project. It is assembled from the following parts: a Raspberry Pi 02W, Arduino camera, 3 objective lenses, stepper motors, LEDs, and 3D printed structure. The design of this project is divided into 3 main parts: the autofocus, the platform, and LED light source control. So the picture on the right shows an algorithm for applying autofocus. It calculates the contrast value of images, refocus until reaching maximum contrast value. It has been successfully done on my project. However, it is running very slow. It could take up to 15 seconds only for taking one picture. This is because the processing time of Raspberry Pi is very slow. If with better devices, we could have reduced the time significantly. But anyway, it is giving clear images. So this is an example of me taking my student ID. As you can see, the upper image is very blurred. You can see barely nothing in there. But after autofocus, you can clearly see my face on the student ID. That is how the autofocus works for images. And the next one is objective lens switching. So as mentioned, I have 3 objective lenses, and I need to switch them automatically on my project. Therefore, as you can see, a circular plate is designed on the right. A stepper motor is connected to the middle shaft of the plate, and the objective lenses are connected to the holes drilled. As the stepper motor works, it rotates the whole plate to switch lenses. So this is a video of actual lens switching in the project. As you can see, the stepper motor works and rotates the whole plate. It switches to the next lens and then stops to take images. Then it switches to the next lens and take images again over and over again in this process. This ensures that all objective lenses are used, so we have multiple magnification factors. And the next one is platform. Since different lenses have different working distances, it means that I need to send it up to different altitudes for the images to be clear. Therefore, a controllable platform is designed. So as you can see, there is a motor controlling the linkages connected to the platform. It can flexibly change the altitude of the platform. The only issue that it needs some lubrication for the track, since 3D printed structures have very high contact frictions. The last one should be LED light source control. Sadly, the LEDs are too bright for indoor imaging, so they are constantly disabled during imaging. And the LEDs just got burnt right after assembling the whole project, so no presentation on that will be shown. And finally is the results part. Theoretically, I should have a thin sample, but I don't have specific instruments on that, so a slice of apple is taken instead. As you can see, pictures are taken under different magnification factors, and they are clear to see the details of the apple. The first one takes the overview of the apple. The second one takes into some details, and for the third one, we can clearly see some details on apple that human eyes cannot observe, even though it is still far away from observing microbiotas, for example bacteria. It is well enough for this project. For further improvement, better devices are desired, for example better processors, better cameras, and better motors. The materials of the structure also needs to be replaced, since 3D printed plastic is not strong enough. The code also needs to be optimized, since they are running slow. Concludingly, this project is well done and has got satisfying periodic results. Thank you for listening.